we set up an augmented matrix of -1, 2, 3, and -6. And on the other side of the bar is the identity matrix. And so what we're working towards is for the left side of the bar to look like this. And then what's on the right side of the bar would be the inverse of the matrix that we started with. First step, I'm going to multiply A by 3 and add it to B. And let me be clear, this is the A that I'm multiplying by. And then to save time and space, I'm going to go ahead and change the signs of A here. So when I do that, I'll have 1, -2, -1, 0. And 3 times -1 is 3, -3, excuse me, plus 3 is 0. 3 times 2 is 6. 6 plus -6 is 0. And at this point, I don't need to go any further because it is already evident that there's no way I'm going to get a 1 and a 1 here. Which means this matrix has no inverse. It is singular. In part B, I'm going to start with the -1, -2, -2, 3, 7, 9, 1, 4, 7. And on the right side of the bar, I've got the identity matrix. So that's 1, 0, 0, 0, 1, 0, and 0, 0, 1. And then what I'm aiming to do is get the left side of the matrix to look like what the right side looks like now. So I've already got my first leading coefficient to kind of be 1. And so I'm going to leave it alone for now. But I'm going to multiply it times 3 and add it to B. So maybe in the interest of space, yeah, let's go ahead and change the sign of A in this step. So -A, and then my new B will be what I get when I multiply my old A times 3 and add it to B. And my new C, I can add my old A and C together and get my new matrix. So here's what it's going to look like. 1, 2, 2, -1, 0, 0. Again, for the sake of clarity, this is the A that I'm doing stuff to. So 3 times -1 is -3 plus 3 is 0. 3 times -2 is -6 plus 7 is 1. 3 times -2 is -6 plus 9 is 3. 3 times 1 is 3. Plus 0 is 3. 3 times 0 is 0. 0 plus 1 is 1. 3 times 0 is 0. 0 plus 0 is 0. And then finally, I'm just going to add my old row A and row C together. This is 0, 2, 5, 1, and 1, and 0 there in the middle. All right, so I've got my leading coefficient of 1 in equation A, equation B. Now let's get the leading coefficient to be, let's get rid of the 2 in equation C. So I'm going to leave rows A and B alone for now, but I'm going to multiply row B by -2 and add it to C in order to get rid of the 2 in row C. So here's what it's going to look like. And again, for the sake of clarity, that's the B that I'm adding stuff to. So negative 2 times 0 is 0. 0 plus 0 is 0. Negative 2 times 1 is negative 2 plus 2 is 0. Negative 2 times 3 is negative 6 plus 5 is negative 1. Negative 2 times 3 is negative 6 plus 1 is negative 5. Negative 2 times 1 is negative 2 plus 0 is negative 2. Negative 2 times 0 is 0. 0 plus 1 is 1. And then first two rows I'm going to leave alone. So now I've mostly got my leading coefficients of 1, and I need to, once again, remember what our goal is. We're trying to get the left side of the bar to look like the identity matrix. So I'm going to do a couple of things in my next step. I'm going to, for row A, I'm going to multiply row B by negative 2 and add it to A. For row B, I'm going to multiply row C by 3 and add it to B in order to get rid of the 3 in row B. And then I'm going to go ahead and change the signs in row C. So, again, for the sake of clarity, my first step, this box is too big. This is the row B that I'm doing stuff to right now. Okay, so negative 2 times 0 is 0. 0 plus 1 is 1. Negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times 3 is negative 6, plus 2 is negative 4. Negative 2 times 3 is negative 6, plus negative 1 is negative 7. Negative 2 times 1 is negative 2, plus 0 is negative 2. Negative 2 times 0 is 0. 0 plus 0 is 0. For the next row, I moved the box in the black matrix so you can see what row I'm multiplying 3 by. So here we go. 3 times 0 is 0. 0 plus 0 is 0. 3 times 0 is 0. 0 plus 1 is 1. 3 times negative 1 is negative 3, plus 3 is 0. 3 times negative 5 is negative 15, plus 3 is negative 12. 3 times negative 2 is negative 6, plus 1 is negative 5. 3 times 1 is 3. 3 plus 0 is 3. And then finally, I'm just changing the signs in the next row. So 0, 0, positive 1, positive 5, positive 2, negative 1. We're almost there. Last thing I need to do is get rid of the negative 4 in row A. And I'm going to achieve that by multiplying row C by 4 and adding it to row A. So again, that's the row I'm adding or subtracting to. Or that's the row I'm multiplying, excuse me. So 4 times 0 is 0. 0 plus 1 is 1. 4 times 0 is 0. 0 plus 0 is 0. 4 times 1 is 4. 4 plus negative 4 is 0. 4 times 5 is 20. 20 plus negative 7 is 13. 4 times 2 is 8. 8 plus negative 2 is 6. 4 times negative 1 is negative 4, plus 0 is negative 4. And then my other two rows are wonderful. 0, 1, 0, 0, 0, 1. Negative 12, negative 5, 3, 5, 2, negative 1. And what we did all this for was this matrix. So the inverse is 13, 6, -4, -12, -5, 3, and 5, 2, -1. For part C, we start with the augmented matrix 4, -6, 2, -3, 1, 0, 0, 1. And there's really no nice, pretty way to get the 1 that I want in my first row. So maybe I'm going to multiply the first equation by 2 and add it to the second equation and see what that new second equation is going to look like. So I'm leaving the first equation alone, 4, 2, 1, 0, or first row alone, excuse me. And two times 4 is 8. 8 plus -6 is 2. 2 times 2 is 4, and 4 plus -3 is 1. 2 times 1 is 2, and 2 plus 0 is 2. 2 times 0 is 0, and 0 plus 1 is 1. Well, this isn't getting me any closer to a 1, but you might be noticing that if I double the left side here, I end up with the left side here. And what that means is that this is singular. Because what I would end up with is what I saw in part A, where I would end up with a row of zeros to the left side of the bar. And when that happens, I do not have an inverse to the matrix. When we have a 2 by 2 matrix, there's another way to find the inverse of it. We can take the determinant of it, which is this value, take the reciprocal of it and multiply it by this matrix, and I end up with the inverse matrix. We can also find the determinant of a 3 by 3 matrix. It's a little bit more involved. This is how we do it. We do not, on paper and pencil, use the determinant of a 3 by 3 matrix in order to find the inverse of a 3 by 3 matrix. The textbook describes a way to find the inverse of a 3 by 3 matrix on a graphing calculator. Since we don't all have access to a graphing calculator, we're not going to do that here. So let's find the determinant of these 2 by 2 matrices and use them to find the inverse where it's possible. So in part A, the determinant is the product of these two things, which is 48, minus the product of, whoops, that didn't work out, minus the product of these two things. So my determinant is 0. And back here, we were told that if the determinant is not 0, then there's an inverse. Well, determinant's 0, so it does not exist. The inverse does not exist. In part B, the inverse of this matrix, let's call the matrix A. So the determinant, of this matrix is 2 times -2, which is -4, minus -2 times -3, which is +6. So that's -10. So it does have a matrix. And so we're going to use that fancy formula that we saw on the previous screen. So that means that we're going to switch these two values and then take the opposites of these two values and multiply them by the reciprocal of the determinant. So That gives us 1/5, -3/10, -1/5. This isn't a negative sign, by the way. And -1/5. For 3x3 matrices, all we will do is find the determinant of it. So we do 3 times the determinant of the remaining matrix, minus 1 times the determinant of its remaining matrix, plus 2 times the determinant of its remaining matrix. So that's 3 times 6 minus 1, see the 6, see the 1, minus 1 times 3 plus 2, see the 3, and it's minus, see the -2, and then plus 2 times, oops, -1 minus 4. See the -1 and then minus, see the 4. All right, so 3 times 5 is 15, minus 5 minus 2 times -5 is minus 10. So the determinant here is 0. Which means its inverse, if I had asked, doesn't exist. Now let's do part B. For part B, I have -1 times the determinant of its resulting matrix, 0, 3, 1, -2. And it's always minus for the second one, but since my second term here is negative, it's actually plus. And then plus 1 times its resulting determinant. So -1 times 0 minus 3 plus 2 times -8 plus 9 plus 1 times 4 minus 0. -1 times -3 is 3 plus 2 plus 4 is 9. My determinant